going now. Okay, so our classes are known as bridging classes now. Okay, and we first start with the concept of element versus compound. We are not studying anything with relation to a course. We are studying to clear up our concepts. Okay, element versus compound. Though we have spoken a lot about it in mixtures and all, let's talk once again about them. Right. So we have matter. Okay, we have matter, and matter is divided into pure and impure. Impure matter, pure substances, impure substances. This part we have already studied. All the mixtures and everything come here. Today we'll concentrate on this. Pure can be further classified as elements or compounds. And note down as much as you want. This is not any chapter of your book. These are for you to understand the basics of chemistry. Elements and compounds. So question arises, sir, what are elements or what are compounds? In both these two things, something is common that they are made up of one kind of particles. They are made up of one kind of particles. This is common for both, right? When you talk about this one kind of particles, right? That thing for an element will always be in the form of an atom or will be in the form of a molecule. But when we see it for a compound, it will always be a molecule. It will always be a molecule. So did we understand what we are trying to say? We have matter. Matter is classified into pure and impure substances. Impures are mixtures, which we just did. When you talk about pure substances can be classified as elements or compounds. What is common between them? They are made up of one kind of particle. That particle, in the case of elements, can be atoms or molecules, but in the case of compound, will always be molecules. Let us now try to understand this thing. Okay, so let's say I have an element, and my element is copper. Represented by the symbol Cu, means cuprum. Okay, Latin word Cu. ये सब सीखेंगे अभी. Book में नहीं रहता है. अब you will become, today my grade 10 people can easily predict formulas and all. That because this chapter was done. This was earlier, year previous this we were to just follow the book, which I feel gives you a problem. So copper. So let's say you extracted a sample of pure copper, right? This is pure copper. And if you go down at a granularity level, pure copper means I can also say that this is matter. Yes, this is also matter. And if I go down at a granularity level, that is, I have taken this much portion out. This is a very microscopic portion which I have taken out, right? And I observe this portion. I find that it is made up of only copper atoms, and nothing else is present. I look back to my definition, made up of one kind of particle. Being an element, here the particles are atoms. Is this clear? Okay? Then only I will say that this is an element. This is an element and it is in its, elements are always in its pure form. So somebody may ask you, is an element a pure form of matter? Yes. Is a compound a pure form of matter? Yes. What is the thin line difference? We will see. An element is also made up of one kind of particle and a compound is also made up of one kind of particle. In the case of element, that one kind of particle can be an atom or a molecule, whereas in the case of compound, it is always molecules. Understood? So what we are doing next is that we took the example. Which example we are done? We are done with this, that they can exist as atom, right? Now copper is also a metal. Right? Let us take the example, our second example of a non-metal. And the non-metal we are taking is oxygen, represented by the symbol O. Right? Oxygen that you find in the atmosphere is actually found in molecular form. Molecular form, where actually two atoms of oxygen combine together and give you one molecule of oxygen. Okay? So if we consider that this is our person, what is he inhaling? He is inhaling a sample where if I go down at the very basic level, what will I see? I will see molecules, molecules, molecules. He is inhaling molecules where each molecule is again made up of two atoms of oxygen. But he cannot touch these yellow ones. What he is only touching is the blue one. Right? So this is a molecule. A molecule comprises of two atoms, like or maybe dislike also. But here we cannot have a dislike because we are again saying one type of particle. So is this clear? Right? Element consists of, please write. If you are not writing, you will forget. These things are very, very significant for your understanding. Element comprises of only one kind of particle, and that one kind of particle can either be an atom or a molecule. Metals usually will come on in atomic form, whereas non-metals will be coming up in molecular form. Like if you want to inhale chlorine, you will inhale Cl2. If you want to inhale nitrogen, you will inhale N2, right? So why is this N2? Why is this O2? Why Cl2? Why only Cu? Why not Cu2? These we will see in the coming stages. Is this much clear? Our next discussion is all about compounds. Our next discussion is about compounds. Now there is no ambiguity with compound. Compounds are always represented by molecules at their granularity level. Then sir, what is the difference between this and this? This molecule will be made up of only one kind of atom. This molecule will be made up of more than one kind of atom. For example, I have a molecule of carbon dioxide. Now this is not called a symbol. This is called chemical formula. ये सब धीरे धीरे सब पढ़ेंगे. This is called a chemical formula, right? This was a symbol. This was a symbol. This is a symbol. This is a chemical formula. Molecules are not, as I keep saying, note down, molecules are not represented by symbols. Molecules are represented by chemical formula. Molecules are never represented by symbols. Molecules are represented by chemical formula. And okay, so if you look at carbon dioxide in the atmosphere in a sample, then we would actually see one molecule of carbon dioxide, which will have what beta? It will have two atoms of oxygen, and one atom of carbon. One atom of carbon. This is carbon, and we have got two atoms of oxygen. This is O, and this is also O. They are chemically combined together. It's not that you have just made them remain with one another, chemically combined. And when I use the word chemically combined, it means parental properties are lost, right? Carbon is combustible, koila jalta hai. Oxygen is a supporter of combustion, but carbon dioxide extinguishes fire. So parental properties are completely lost. This is a chemical combination. You just can't reverse it so easily. Okay? So before we end this slide, and our first discussion today was on atoms and molecules. Slowly as we go down, we'll talk more on atoms and molecules. So before atoms and molecules, we spoke. Yesterday only I swept the whole class. Today she's erasing it. Look at her. At grade 9, why do you need to erase so much? Next time you'll bring a dustpan and a brush. मेहनत होता है भाई इसको साफ करने. Okay, we spoke about elements and compounds. Elements can always exist either in atomic or molecular form, whereas compounds will always in molecular form. So it was very nice to say all molecules need not be compounds, but every compound is a molecule. Every compound is a molecule. All molecules need not be compounds. So if you want to see it from the perspective of atoms and molecules, we can again have some further division like this. Look, this fellow is an atom. This fellow is an atom. He can contribute only in element, pure form. This fellow is a molecule. This fellow can represent an element, can also represent a compound. Have you understood? If you still want example, this is copper atom. This is oxygen molecule. This is carbon dioxide molecule. Okay? And just for our knowledge, we'll write, while this is the symbol, this is a chemical formula. Chemical formula. Right. So a chicken and egg story. A chicken and egg story. Now, you want to reach at matter. You want to reach the road of matter. Right? This is your destination. Let's begin our journey. How do we reach to matter? So, our first building blocks will be atoms only, because atoms can make molecules. Molecules cannot make atoms. Right? And who are contributing to these atoms? Who are contributing? There are 1, 2, around 114 elements are contributing to these atoms. Means we can have as many as 114. Now this is a very debatable subject. There can be 114, 116 artificially manufactured. Right? All these elements are represented by their atoms. That is what is this periodic table. This periodic table is like the United Nations Charter, where every country is represented by one desk. Every element is represented by one atom. When you see, so for example, you are seeing lithium out here, it's one atom of lithium just. And that one atom of lithium, why do you say that? Is it lithium? Yes, he's going to behave the same way as you bring one block of lithium. This person who is representing India in United Nations is all empowered to take all decisions on part of India. What he speaks is what India speaks. What you see from lithium here is what lithium is going to show. Have you understood? And so we would be sending our most literate, knowledgeable, and most efficient and capable person. In fact, we will send a person with zero defect. So these are people who are the best in the lot. They are not those lithiums who have combined with somebody and formed lithium oxide, lithium sulfate. They are just pure form of lithium. Clear? Samajh mein aaya? So a lot of elements are there which are going to have atoms. So similarly, you will have how many atoms? You will have atom A1, you will have atom A2, and such maybe atom A114. Right? Any one particular atom can be an element in pure form. Do you agree? Can be an element in pure form. They can combine. Let's say we are having gold. Lots of gold atoms in pure form forms pure gold. And pure gold can also reach the destination, which is matter. Is this clear? Okay. Another option can be that A1 combines with A2 and forms a molecule M1. Right? And then lots of M1 give a pure form of a compound. Rather, it's wrong to write that word pure form. Compound is always pure. So we will say that lots of these M1s can represent what is known as a compound. Do you agree? And then also you can make matter. Understood? Now, when these process is happening, this is a chemical change. Means they are chemically combining. Right? Okay. After that, we can have one more road where we take either 1 or 2 atoms, take one molecule, and just physically combine. Physically combined means you are trying to make a bhel puri out of it. You arrive at something which is known as mixture. You can still become matter. Story clear hua hai? The same figure I have drawn from bottom side. So in order to understand their family right from the root, we should have to go at the atomic level. Our next discussion will be on atoms. Okay? So no matter what type of matter you see, if you see a black forest cake, as I always say, the black forest cake is going to have milk. Milk is going to have calcium. Milk is going to have sugar in it, which is in the form of, say, lactose. Sugar will have carbon, sugar will have hydrogen, sugar will have oxygen. So ultimately everything, and the black forest cake is a lovely mixture, it's not a compound. So ultimately everything is boiling down to atoms, atoms, atoms. And how many different atoms? 114 different atoms, whichever way you want to play. Clear? यहाँ तक लिख लीजिए, and then we will see our next part. Okay. Shall we? Yeah. Please write down whatever you want to write down. The next time when you're in class, this thing should be thorough to you. You should not have any ambiguity. What is element? What is compound? What is an atom? What is a molecule? What is a mixture? ठीक है, चलाए? चलो. Is it fine, or are you still need some time? Done. Okay, let's move. Our next discussion is on the atoms. So we just had a discussion that if you have matter, the last form of this matter is, end of the day, atoms. Atoms. I was seeing some nice videos, you know. What happens is, ever since the universe is made, you can listen to some stories like this, you know. When the universe got made with the Big Bang, you had only hydrogen and a little bit of helium. So it was all those stars. Hydrogen fusion happens and helium forms. Helium fusion happens, carbon forms. That's how carbon came up. And these all sorts of things keep on, new atoms were made, and they started exploding into the atmosphere. Some formed into lumps and all. So whatever is you today, what is your body? Your body is having also many atoms inside your body, right? And every atom that the atoms are entering your body, many of the atoms are dying also. New fresh atoms are coming in. Actually, just to see an example, you are eating a vegetable. The vegetable has got those atoms. So those atoms are fundamental. They are coming from the vegetable, entering into your body, right? And after that, what happens? You are growing, your tissues are growing, bones are growing, new atoms are coming up. But the question that arises is, after that, you will find death is a very nice mystery. You will find that every atom that is coming in your body, also there are atoms which are leaving your body also. You're exhaling carbon dioxide. There's the excretory system working in you. So atoms are going out. How does the atom... So do you agree one thing? New atoms are coming, new atoms are going out. Then in that case, you are changing dynamically. How is your memory remembering every day what happened yesterday? Just imagine, these are so nice discussions. Are you able to understand what I'm saying? Every day, new maids are coming in your house and leaving. You're having a maid every day. But how come the maid knows where is sugar, where is jeera, where is dhania, where is turmeric? I was born as a child, right? Initially, I was only on milk. So I had a class of atoms which went in. Then my mom and dad started feeding me something different type of things. New atoms are coming in. Every day new atoms are coming in. As a child, I also have my excretory system. Some atoms are going out, right? So might be there is a plant took nitrogen from, so going out. But the question is, so everything is replacing. How come they are remembering? You remember everything in your mind. So it's like this. The atoms and all are all like dancers. Your body is a pattern. Your body is a pattern. Once the atoms are in your body, they perform the pattern and then leave you, right? Say suppose whatever waste has been excreted from your body, that has again gone to the universe. Might be it has gone and formed a part of manure, or it has gone and now going in somewhere. So it is now going to perform that pattern. The pattern continues. So once we die, afterwards what will happen? Wherever we are, we will decompose. All our atoms will be decomposed. So all the millions of atoms which are in our body again go back to the universe pool. So all these planets which you see are lumps of atoms. You yourself are also an universe which is looking at the universe also. Naapko nahi lagta hai? You are also a lump of atoms, man. Just that you have your program, your pattern is something different. And your pattern is such that you can talk, dance, or you can mix with people and all. So in physics, the thing is that it's just a changeover of atoms. Those atoms which came into my body, it is time for them to leave my body. What happens in a sun or something, or a star? An explosion happens, a supernova forms, again many things will be going out. So that's the story. So if you look at matter, the last entity that I can find is atoms, right? Let's enter inside it. So we are going into the subatomic level. At this level, we actually find three kinds of particles when we go inside an atom. The first kind of particle is known as the electrons. Typically denoted by E, these are negatively charged particles, negatively charged, right? These are negatively charged particles. Negatively charged particle. And particle means this fellow must have some mass. Agreed or not? Right? So the atom has electrons, and then inside the atom we have another body which is known as the nucleus. As the nucleus. And inside nucleus, whoever stays in the nucleus, we call them as nucleons. Nucleons. People who stay in India are called Indians. People who stay in nucleus are called nucleons. Nucleons are of two types, protons and neutrons. Very interesting. Protons and neutrons. Understood? Protons are positively charged particles. Neutrons are electrically neutral. We call them electrically neutral. These are also particles. Particles. You're also like a planet, a growing planet. And one day everything finishes in your planet, you decompose. Meteorite jaisa ho, jaan hai aap mein. And doing that, you're looking at the other universe also. You're a very blessed organism. No other person has that idea. The beauty with the human race is we have two things: the power to think and speak, and the knowledge of time. That we will die one day is only known to us, not to a dog. And the knowledge of time. Does a dog know that what is 23rd of March? No. It just knows that light comes up in a day, light goes back in a day. It doesn't know what is yesterday. It doesn't know what is tomorrow. That you know. Okay. Neutrons, protons. Now when we talk about in terms of mass, let's talk raw. I'll not talk numbers out here. I'll just give you ideas. Mass. In terms of mass, the mass of a proton, is similar to the mass of a neutron. No, neutron. They are heavier bodies. Their mass is around 9.1 into 10 to the power minus 27 kg. Not to break your heart, though the mass is same. And they are all present in the nucleus. That means the nucleus is a damn heavy thing. It has got two heavy particles which are there in the nucleus. Together we call them nucleons, right? And when you talk about the mass of an electron, it is very, very less. It is by 1/1840 times the mass of a proton. बहुत ही हल्का है. An electron is very less, very less. In fact, electron as a particle is never seen. Electron is seen as a wave. When you wear a white shirt and you go to your school and come back, have you seen the back of your collar? Sometimes a dust band gets created, right, out here. Did you see those dusts? No. But they were particles, almost like a wave which have left an impression on your collar. An electron also leaves an impression only. You can't see an electron like a tuck, 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 pearl money or something. It's very light. 1/1840 times the mass of a proton. Proton itself is light. Electron is how much? Almost 1/1840. Understood? So in terms So who is the lightest? The lightest particle is the electron, and these two are almost similar. This will give you a fair bit of idea about the atom. Now let's talk about charge. Let's talk about charge. Matter always will show two properties. One is mass, one is charge. So in terms of charge, the electron charge is equal to the proton charge. Proton charge. In terms of magnitude, you know, value. If you want to write this, you should know. So the charge of both of them is 1.6 into 10 to the power minus 19 coulomb. 1.6 into 10 to the power minus 19 coulomb. C stands for the scientist coulomb, and this is the SI unit of charge. The SI unit of charge is called coulomb. Both have 1.6, but in books you will see that the electron charge is shown as negative, the proton charge is shown as positive, whereas in terms of magnitude they are same. Do you understand? So we are in a position to picturize how does our atom look like, right? So our atom definitely has a concentrated zone of mass, which is what? Which is the nucleus. The nucleus is damn heavy because it is containing what, beta? It is containing nucleons, both of which are of equal weight, right? And one is electrically neutral, however, one is charged. So the nucleus has got a lot of energy in it. It is binding all heavy particles to it. That's why when the nucleus explodes, huge amount of energy is received. That is nuclear energy. Can be used for very destructive as well as constructive purpose, right? Now, this is our nucleus, and around this nucleus, we have something called orbits. At your level, orbits, but when we go at higher level, these orbits will also change, and we'll call them as orbitals. These are orbits, and in these orbits, our cute little electrons are actually present or moving. This is the basic structure of our atom. Have you understood? Generally, we will henceforth not show you like this. We will be showing you it in concentric circle manners. ठीक है? तो हमने क्या सीखा इस स्लाइड में? That all matter fundamentally comes down to atoms. In an atom, when you go inside subatomic level, you get a particle which is called nucleus. That is the central core of the atom. This one, damn heavy, consists of nucleons. And what are nucleons? Neutrons and protons. So the nucleus, if somebody says, what is the charge of a nucleus? Positive. End of the day, the nucleus is positive because it contains protons. And the nucleus is like that mother whose children are cycling in and around the society campus. And who are the children? Electrons. Very lightweight. If we talk in terms of mass, the mass of the nucleons are same. But if we talk in terms of charge, the charge of a proton and electron are same. Have you understood? And how many such atoms? 114 such atoms. So definitely there has to be some sort of difference in them. So a nice discussion out here. And that discussion is, let's say I bring two atoms, okay? My blue atom, this is an atom. This is not nucleus, children, okay? This is an atom, and this is an this is a study for an analogy purpose. I have with me, say, an atom of sulfur and an atom of carbon. Sulfur is S, carbon is N. Are they alike? Not at all. Not at all. They have a different combination. But when we enter subatomic, let's take a sulfur atom and get inside. What are we getting? Electrons, protons. They are not sulfur electrons, carbon protons. They are just electrons. They're just electrons. So the next question is, sir, is the electron of a sulfur atom same as the electron of a carbon atom? Absolutely. And the best example I give is, all these electrons, protons and neutrons are the various vegetables available in Ratnadip. A Telugu guy came and brought bhindi. A Bong guy came and brought bhindi, and a Punjabi guy came and brought bhindi. Will they make the same vegetable curry or same sabji? No, right? So their sabjis are different, but they were made out of the same bhindi which was purchased from the same shop. So the electrons that you get out from what you call sulfur, or the electrons that you will be getting out from neon or carbon or oxygen, उनमें कोई फर्क नहीं है. Electron like this, all are same. You won't be able to hunt. But the way they combine, that's what I said. The same atoms, if I eat palak and she eats palak, we are eating the same palak, brought from the same plant. The same atom entered her body, my body. But when it's entered her body, it behaves her configuration. When it entered my body, it is behaving my configuration. That's the beauty of the universe. Is this understood? Right. Shall we go a step more inside? Okay. Our next topic. Our next topic is about two identities which you should know that are known as atomic number and mass number. Very good. And mass number. Now, Mishka, do you feel all these things last year? Huh? Atomic number and mass number. But there is an age to understand, na? So let's understand once again. 7th grade, because DPS is the only school which used, being a CBSE school, used to follow a ICSE book up till grade 8. That's the reason you have learned. Okay. So let's talk about atomic number and mass number. Atomic number is an identity of an atom. It is equal to the number of protons, or I can say count of protons, represented by the English letter Z or Z. Z or Z. Okay. So let's take an example of an element. We have an element whose name is oxygen. Right? Symbol is O, and in oxygen, the atomic number of oxygen is 8. Slowly hum seekh jayenge. Its number is how much? 8. That means oxygen contains, not oxygen, one atom of oxygen contains 8 protons. 8 protons. Banate हैं इस atom को. Start making it. So this is my nucleus, and in this nucleus I will have how many protons? 8 protons. 8 protons are there. 1, 2, 3, 4, 5, 6, 7, 8. Understood? Right? Now, in order for this atom to exist, this bottle is existing. It is existing because it is electrically neutral. Otherwise, it should have been an ion or a charged particle. It's not charged right now. So, if an atom of oxygen ever exists, later you will find that this does not exist. This does not exist. None of them exists. They are all the girls on the portal of shadi.com. They are the most good looking, most well behaved. They never fight. They never throw utensils. They never throw tantrums. These are those girls. In them, there are some girls who are actually very good. Inert gases. Can you marry them? No. Huge demand. You will get only these. The moment you bring them home, you will say, "Kaun? मैं क्यों करूं? चल बर्तन मांज, मैं नहीं करती." But here, this is the photo of shadi.com. So, periodic table is a shadi.com, which represents the atom in the most stable manner. वो stable नहीं है. सर क्या कॉपर के एटम्स दिखते हैं? मुझे नहीं दिखते हैं. नहीं दिखते हैं. But sir, so many AC pipes are there, all are made of copper. No, they are impure copper. They are combined with something. They are copper oxide, copper sulfate, copper chloride, copper hydroxide, whatever, but not copper. But sir, I have heard that gold is very pure. No, even gold combines. The only pure thing in this world are inert gases. वो आगे पढ़ेंगे, ठीक है? तो हमने यहाँ पे कितना कर दिया? Now, in order for this to be electrically neutral, eight positive charges have come. How many positive charges? There should be 8 negative charges also. Very good. So 1, 2, 3, 4, 5, 6, 7, 8. So I should have 8 negative charges. That means I am writing this atom should have 8 numbers of electrons also. Have I made it electrically stable now? Yes. So some books will also write that the atomic number is also equal to number of electrons, wait, hang on, in a electrically neutral atom. But when you go to hunt this electrically neutral atom, you are hunting that shadi.com girl. You will not find her. She exists only in those portal. नहीं मिलेगा आपको. That means 1 or 2 electrons will be off. However, protons are never off. Protons are with the mother. Anything in nucleus is called bounded. We should also understand the meaning of two things. Bonded versus free. The electrons are something which are free particles. Electrons, I'll not say free particles. Electrons will show free behavior. Protons cannot show free behavior. They're bonded. And when you break this, you are bringing catastrophe. Atom bombs, okay, radiations, decays, something catastrophe will happen. Something bad is going to happen. But these are free, okay? Apart from this, we should also have what? We should also have another particle which is electrically neutral, which is known as neutrons, okay? So in oxygen, I know that I have got 8 neutrons. There are 8 neutrons. This is precisely a oxygen atom, 8 neutrons. Understood? So now I start my next measurement, which is known as mass number. The mass number is the count of nucleons, which is equal to, now more standard, okay? Oh, anything when we do a sum, we call it a sigma, okay? Anything which is a sum. A sum in mathematics is represented by this symbol. This is sigma. This is capital sigma. There's a small sigma. This is capital sigma. So this is called the sigma of protons plus neutrons. Right? Denoted by the letter A. Denoted by the letter A. Right? So one atom of oxygen contains 16 nucleons, which is its mass number and which is its atomic number. Time for us to dress up oxygen now. Oxygen will be written as O, Z, A. A equal to 16, Z equal to 8. So any element X with a Z and with a A. This is how you represent. Everything will be represented like this, the Z and the A. A stands for mass number. Many people say it is atomic mass. No. Atomic mass, if you see, periodic table does not show mass number. Periodic table shows atomic mass. Look, it is writing, no, there's a difference here. Periodic table says chlorine 34.45. How did you get a point? Did you take a nutcracker and crack one proton? So there is a difference. Mass number and atomic mass are different things. Though people say, hey, what is oxygen's atomic mass? 16. No. Mass number is 16. Atomic mass will always have some fraction with it. वो आगे सीखेंगे. ये सब बुक नहीं सिखाता है यार, इसलिए मजा नहीं आता है. इनको सीखना जरूरी है. ठीक है? Any questions here you can ask me. Any questions at this stage? हाँ जी? Small signal is ulta 6. 6 written like this. Little, it's actually more bent. Actually, it is like this. This is sigma. These are Greek letters. But in printing, they will print sigma like this. They'll print sigma like this. Like this. This is sigma. Assignments. फिर इतना समझ में आया? Okay. Then comes the very nice chart which you will bring next day to my class, called the periodic table. The periodic table is where I arrange all the elements in the order of their atomic numbers, in the order of their atomic numbers, in increasing atomic number, right? So a periodic table is typically identified by something which is known as rows and another is known as columns. Rows and columns. Rows are known as periods and columns are known as groups. The modern periodic table has 7 periods and 18 groups. 7 periods and 18 groups. Okay. 7 periods and 18 groups. Earlier groups were represented like 1, 3A, 3B, abhi aisa nahi. It says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in that manner. Now, as a student of grade 9 and 10, you should be familiar with what is known as the first 20 elements. The first 20 elements. Okay? Itna karke hum aaj chhodenge. First 20 elements. So let's see how are the first 20 elements placed. Okay? Let's see how are they placed. So in order to see the first 20 elements, we will have we'll have to make our columns. Should I make so many? They'll get confused. 20. Okay, let's start. We will have, I'm making it freehand, otherwise it will take a lot of time. Say, we have 18 columns, okay? Just don't make straight away, wait for me. This is group 1. Every column is known as a group, right? And I am now supposed to know how many? Only first 20. The first 20 does not involve all the groups, okay? So this is one more, which is the 18th column, the first column and the 18th column. And the first period is only limited to the first and the 18th. This is the first period. This is period 1. And this is group 1, group 18. Okay? Group 18 are known as, I said na, there are some which are absolutely good girls. Inhe nahi milenge aapko. Yeah, they are the inert gases. They are also known as noble gases, and they are the only ones which will be available in atomic form. The entire group. The entire group. The rest, none of them will be available in atomic form. Please remember that. They are the only ones who will be available in atomic form. And they are helium. Helium will come in group 18, period 1. Are you understanding? Group 18, period 1. After that comes neon. Group 18, period 2. After that comes argon, krypton, xenon, and radon. Okay? So we are having 1, 2, 3, 4, 5, 6. इसके आगे हम नहीं देखते हैं, उतना आया नहीं है अभी तक भी. So obviously there should be something like this, and there should also be one which is like this. In fact, I will make this with solid line. Up to helium and neon, your periods, this is period 2. This is period 2, right? So we need to know only 20. In this 20, all these are not coming. So this is my atomic number 1, hydrogen. This is atomic number is 1. comes to helium 2. Helium is 2. Okay. Then comes lithium, which is 3. After lithium will come one more, whose name is beryllium. Now, once beryllium has come, you have entered in group 2. Okay. After this, you will have group number 13 coming up, boron. Boron. After 13, you have 14, 15, 16, 14, 15, 16, 17, 14, 13, 14, 15, 16, 17, and this is 18. This is boron. Boron, carbon, nitrogen, oxygen, and then what? Fluorine. 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 Okay. Fluorine. So how many? 1, 2, 3. This is 4. This is 5, 6, 7, 8, 9, 10. Right? Next. Hydrogen, lithium. Then will come sodium. Here you will get magnesium. Magnesium. Okay. And then boron के नीचे you will get aluminium. Carbon के नीचे silicon. Nitrogen के नीचे phosphorus. Oxygen we will get sulfur. And fluorine we will get chlorine. Okay. Under lithium is sodium. Right. Then we will get potassium and calcium. That's done. 20 are done. You can calculate 4, 5, 20, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. These 20 should be by heart with you. How they are spread. This will help you. Okay. So there are many formulas. There are many formulas. If you want to know group 1 in more stylish way, you want to know. Group 1 is a very simple formula. है लीना की रूबी से फ्रेंडशिप और है लीना की रब से फरियाद. है लीना की रब से फरियाद. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. This one is very easy. बेटा मांगे कार स्कूटर बाप राजी. This is beryllium, magnesium, carbon, scandium, strontium, barium. इतना करके कर सकते हैं. But this is not your important. This also, if you know, is good. This is known as the halogen family. This is known as halogen family. Fluorine, chlorine, then iodine, acetylene, acetylene. So just this is called the halogen family. Fluorine, chlorine, bromine, then iodine. Fluorine, chlorine, bromine, iodine, acetylene. This will come like this. Heck. ठीक है, इतना आपको जानना चाहिए. So the ones that you should know are, let's see the ones you should know. Hydrogen. So remember like that. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. After that comes, but we'll write it again, potassium, calcium. 20. The beauty of periodic table, now you'll slowly start understanding. How do you keep your masalas? You will never keep sugar between two jeera and dhania. Sugar will be with tea leaves only. So you will see these properties will be same. They will behave in the same manner. Their reactions will always be same. That's why knowing the periodic table will help you a lot. So shall we write the 20 and then leave for today? Let's write the 20. The first one is what? Hydrogen. Number 2, helium. Helium is Ig, inert gas. So you will be learning 3 inert gases: helium, neon, argon. Helium, then hydrogen, helium, lithium, then beryllium, then boron, then ये हो जाएगा यार, don't worry. Carbon. After that, nitrogen, then oxygen. Also know their symbols also. After oxygen, fluorine, then neon. The first good boy, the second good boy, Ig, another Ig. After neon comes sodium, then magnesium. बेटा मांगे कार स्कूटर बाप राजी है, लीना की तरफ से फरियाद या रूबी से फ्रेंडशिप। आगे यह भी है, these all things are known as, you know, this is known as the transition element, D block. Here all metals will come up. Metal means metal, मारने से टांग टूटेगा, tungsten, iron, vanadium, chromium, scandium, all these you will get. Okay, number 13, magnesium. After magnesium you will straight away go below boron, so it is aluminium. Then below carbon, silicon. Then below nitrogen, phosphorus. Then below oxygen, sulfur. Then below neon, sorry, below fluorine, so it should be chlorine. Then below neon, argon, your third Ig. And then 20. How come it become 20? कुछ तो गलत कर दिया। 1 2 3 4 5 6 7 8 9 10 11 12 13 14 13 14 15 16 17 18 19 is potassium. Potassium is represented by the formula K, calcium, and 20 is calcium. This should be by heart with you, and we'll keep on writing periodic table many times. 4-5 बार लिखने से समझ में आ जाएगा. It's just remembering all your mom, dad's friends flat numbers. How do you remember them? ठीक है? Did you understand till this much? We have to understand a lot on this periodic table, lot of behavior on this periodic table. Then our chemistry will become very easy. Our next thing is, why do we not get pure atoms in there? Why are those things all natak? That we have to understand. And what is so different in this group? These are known as colony ka acha bachcha, the good boys of the colony. The entire periodic table, they will say, inke jaisa bano, inke jaisa bano. Silicon, 14, aluminium, boron, Si. Any symbol you want, you can ask me. Silicon is Si. Want me to write them? Okay, hydrogen is H, helium is He, lithium is Li, beryllium is Be, boron is B, carbon is C, nitrogen N, oxygen O, fluorine, neon, then sodium, natrium, okay, magnesium. After that, aluminium, silicon, phosphorus, sulfur, chlorine, argon, calcium, potassium. Okay. Okay. Interesting? Was not boring? So today we stop here. Till this much you please revise. Next time when you're coming, this story should be clear. We will spend now some classes on this only. Anyway, your school is not going to reach to the 3rd chapter. So this is your time to learn chemistry the way you should fall in love with chemistry. Okay? Very good.